Okay, so what do we expect the answer to look like here? We're trying to, if we read the question, it says solve the system of equations algebraically, enter an exact answer as an ordered pair to form x, y. So what's the answer going to look like? Well, it could be. It might be no solutions, it might be infinitely many, or it could be 2 points. It could be a point with a value of x and a value of y, right? An ordered pair. So let's go through this one then. So how am I going to get there? What's my strategy going to be to find that value of x and the value of y, ordered pair? Can I use substitution? I mean, not conveniently, right? How come substitution's a bad choice on this one?
A lot more steps.
A lot more steps. What else?
Elimination, simple.
Simpler. Substitution is going to be tough because if I try to isolate a variable in either of these equations, I'm getting fractions, right? I'm going to have to substitute something with fractions, which isn't the end of the world, but it's not our first choice probably, right? We'd rather not. So we want to use elimination, right? Remember that elimination, let's just kind of quickly remind ourselves, it's been a weekend, so let's quickly remind ourselves what that means. Elimination means if I'm going to add the equations together, I want to get it so one of the variables, at least one of the variables is eliminated or canceled. It doesn't happen right now. If I add these up, I'm going to get a negative 3x, negative 11y, and negative 45. So I get a new equation, but it doesn't help me. It's still got both x's and y's, right? So we got to tweak this so that it does help me. All right, so how are we going to do that?
Times the top by 5.
Okay, top by 5. Multiply the top one by 5 and the bottom one by what? 2. Okay, that's a good choice. What's that going to do? How's that going to help?
It's going to cross off the x's.
Okay, good. If I distribute a 5 through the top, I'm going to get a 10x from my first term. If I distribute a 2 through the bottom, I'm going to get a negative 10x. That's what we want, right? Then the x's, when I add them up, will cancel out. So what do I get for all the stuff if I distribute a 5 through on the top?
10x.
10x.
Negative 25.
Good. Minus 25y.
Plus.
Good. Negative 35. If I distribute a 2 through the bottom, there's my negative 10x. What else?
12y equals negative 76.
Okay, and if I add those up, just like we hoped, the x's cancel. That's good. Negative 25y plus negative 12y is negative 37y. And then how about over here? They're both negative, so I'm going to add them together and get a big negative, right? There you go. 30 and 70 is 100. 5 and... did I mess that up? I think I did. That should be 76, shouldn't it? Yep. My mistake. Let me fix it.
It's still...
Yeah. So that's a 6. And so we get negative 111. Negative 30 and negative 70 is negative 100, and then 5 and 6 make 11, right? Okay, what do I do to get y by itself? Divide by negative 37. And what is negative over negative is positive 3. Good. Okay, so that's one of the 2 parts of my solution. How do I get the x part, the x answer?
Plug y.
Plug it in. Good. Does it make, I mean, they'll both work, but is there one equation that might be a little bit better?
Yeah.
Maybe the top one, slightly smaller numbers, right? So we'll plug y equals 3 back in right there for that y. And then that first equation, if I do that, becomes 2x minus 5 times my y value I'm plugging in equals negative 7, and I'm plugging in a value of 3, right? So that's good. Now all I've got to do there, I've only got a single x, so all I have to do is isolate it, right? What, if I multiply negative 5 times 3, I get 2x minus 15 equals negative 7. So now I want to isolate the x. So I want you to think here, what are going to be the 2 steps in order that I want to execute to get that by itself? Okay, Patrick, what am I going to do? If I want to get x by itself, what do I do? 2 steps in order to get x by itself.
Add 15 and then divide by 2.
Good. Add 15 and divide by 2. Do that in your head. Let's do a little mental math here. So if you add 15 to the right side, and then to divide the result by 2, what are you going to get? 4. Good. I'm going to get 8 divided by 2 is 4. Okay, so now, how about this? Is this an okay way for me to enter my answer? Could I say, like that, put that in the middle?
You need parentheses.
That's not enough, right? I have to have parentheses. Ordered pairs have to be included in parentheses, and that's our math way of reminding us that that's a value of x and a value of y. Think about it in terms of a graph. You know, we looked at this stuff graphically also, and when we solved the linear system, that's just one line and then a second line. What are we really looking for? What's the solution going to be if I've got these two lines? Where they cross, point of intersection. Well, that's a point, right? That's how we write a point. We have to put a point as an ordered pair in parentheses. Same thing even if we're not doing it graphically. Okay? All right, does that make sense? How could I check this?
Plug in.
Plug it into just one of the equations? Both of the equations. Good. All right, so what about something like this guy? Solve the equation. This is the other one. This was also tied for the one that the most people had trouble with. So let's talk about it, and I can see very clearly from looking at the data here exactly where people are having the trouble. Here's what people are trying to do with this. People are trying to, a lot of times they'll add 8 to the other side, but then they'll try to distribute the 4, right? We can't do that, right? We have to break this into 3 distinct parts. First, we have to isolate the absolute value. Then we break it into 2 separate equations, and finally we can do some algebra on the stuff that's inside. So here's another way to think about this. I'm gonna give you another approach, another way to make it kind of internalize this so it makes sense. So we can't do anything inside the absolute value bars at all, right? We can't do any algebra there because the absolute value bars lock up the stuff that's inside and make it, it's like it's in a safe. We can't get to that. Can't do anything to it. So I'm just going to replace it with that. And replace it with a bubble, right? And I'm going to make it look like one big variable. Call it x, right? How would you get that x by itself? Add 8 and then
Divide by 4.
we have to do the same thing with absolute value bars. You have to treat the whole absolute value as one big thing. Call it the bubble. And you can't do anything to that until you've gone through all the steps to get rid of the absolute value bars and replace it with equations, right? So the first step is get it by itself. So you're telling me add 8 and divide by 4. Okay, so if I do that, if I, oh, this would be cool. Oh, yeah, like this is good. So then to get that by itself, I'm going to have 4 times the bubble equals, if I add 8, 128, right? If I divide by 4, then what do I get? 32, good. If I divide something by 4, what's another way of thinking about that? 25%? I could also just have it twice, couldn't I? Cut it in half and then take that answer and cut that in half. So what's half of 128? 64, half of that. 32. Okay, so we're down to there, right? So I got the absolute value by itself, right? Now we got to make, what's the next step? What's it going to be, Luke? Okay, I could uncover the x if I want to, but I can't really do anything. If I do uncover the x, if I move this thing away, what's back there? Well, I've still got an absolute value. I've still got an absolute value of something, right? I still can't do anything to that absolute value because as long as it's there, I can't do any algebra. So now what do? If I get the absolute value by itself, how am I going to get rid of the absolute value? I've got to make a trade, right? So what's the next step? Whatever's inside the absolute value bars, right? We don't care what that is yet. Right? Whatever's in there, just think of it as being, let's do this. Let's think of it as being the absolute value of our bubble. Okay. Now the bubble is just what's inside the absolute values. What do I do with that? What's it got to equal? Either what's inside, could equal negative 32, or it could equal positive 32, because the absolute value is going to make it positive whether it starts off as positive or negative, right? So the next step. So step 1 was we isolated the absolute value, right? Step 2. We're going to get two equations. Either what's inside is equal to positive 32, or what's inside equals negative 32, right? So step 2, we're going to create two regular equations. And by regular, we mean they don't have what? The bars, the absolute value bars, right? So now we got rid of those, we traded it for two regular equations, and now finally, we can look and see what's inside the absolute value and solve the equations. Well, what is it? What was in there? Let's see. Turns out it is a 4x minus 24, right? So finally, we can come down here and say, all right, 4x minus 24 equals 32, or 4x minus 24 equals negative 32. And then finally we get to do the algebra. Now we solve for x. But we don't even look to see what's in the absolute value until we've gone through those first steps. So we've isolated it and traded for two equations. Now we look inside. What are the two steps going to be to isolate x?
To add 24 and then
Add 24 and then
divide by 4.
divide by 4. I'm going to do the same stuff to both sides, right, to both of the equations. I'm starting with different values on the right, so I'll get different solutions, but the algebra steps look the same. So, step 3, solve. So if I add 24, I get 4x equals, what is that, 56, okay? So what's half of 56 and then half of that? 14. Okay, so there's 1. Or, if I add 32 here, what's negative, or add 24, what's negative 32 plus 24?
Negative 8.
Good. Divide by 4?
Negative 2.
Okay, so those are my two answers, right? Now this time if we look at Moodle, look what it's asking us to do. It says if multiple solutions exist, which they do, separate the solutions with commas. So what would, if this is my answer box in Moodle, right here, what am I going to input?
2, negative 2.
Okay, so this time it'd be a 14, comma, negative 2, but no parentheses, because it's not an ordered pair. It's just two different solutions, right? Two different values of x. That's our Moodle shortcut way of saying two things, of saying x equals 14 or x equals negative 2. But we're just, we can just take a little shortcut here. I just want you to put in the values, the solutions for x. If there's more than one, just put a comma between them. Okay? Make sense? Okay? All right, those were the two worst ones. This one was not great either. This was the third place one. So how do we write an equation in slope-intercept form for the line going through these 2 points?
Y2 minus Y1.
Okay, good. So, and what are you calculating when you do that?
The slope.
Slope, good. Okay, so we want to fill in the blanks here. We know that we want to write this in slope-intercept form, mx plus b, and so that means we just need to fill in the number of values for m and b, and we're done, right? As long as we specify a slope and a y-intercept, we can graph any plane, or any possible of the infinite lines on the plane. We want the one that goes through those 2 points. So we start off with the slope formula. So what are we going to subtract on the top?
Negative 2 minus 4.
Okay, I could do negative 2 minus 4, so that y value minus that y value. If I do it that way, what has to be on the bottom?
5 plus 10.
5, good, 5 minus negative 10. Okay. Okay, I could also do it a different way, and either one would work. This is probably the easiest way, but what's the other thing I could subtract on the top? Instead of doing negative 2 minus 4, I could do 4 minus negative 2, right? I kind of have a choice with which way I want to do it on the top. But if I do it that way, if I'm subtracting this y value from that one, then what do I have to do on the bottom?
Negative 10 minus 5.
Negative 10 minus 5, right? Either one's going to give me the same answer, so let's just use this one. How about it, right? So what's that give me then? My slope is negative 2 minus 4 is
Negative
negative 6 over,
15.
good, minus a negative is plus, so 15. And what's that reduced to?
Negative
2 over 5.
2/5, good. So there's m, right? So at that point, that's helpful. At this point now, we could move down and write our equation as negative 2/5 x plus b, but I still have to find b. So what's my strategy going to be for finding the value of b?
Plug in one of the ordered pairs.
Okay, good. Plug in a solution. Now, what I want you to see here is that this isn't just something that we're doing during our review for lines. Later on in the year, we'll do stuff like this. I'm just going to give you, I mean, we're not going to deal with this right now, but we might have a problem like this later. Let's say we've got something like y equals ax squared plus bx plus c, and we find the values of a and b. Let's say we find the values of a and b to be negative 1 and 2, but we don't know what c is. How do you think we're going to find the value of c? We'll talk about this stuff later. This is for the future, not too far in the future. But the graph of this would look like a parabola, because it's quadratic, right? What if I know that my parabola goes through the point 4, 5? What could I do? I could plug it in. I could plug in values of 4 for my x's and 5 for y, and then would you agree if I did that, the only unknown would be c? I could just solve for it then, right? Same thing, right? So we can do the same strategies. We're going to use it over and over again. We're just starting off easy with lines. Okay, so if we plug in, which point?
5 negative.
Yeah, it doesn't matter, right? But that's just a little bit smaller numbers, so let's use that point. That's a point that's on my line, so it's a solution. So I know it has to work. So we'll throw in 5 for x, negative 2 for y, and we get what? Negative 2 equals.
Negative 2 is times 5.
Good. And I'm going to write the 5 as a fraction. Put a 1 on the bottom. Plus b. Okay, so Aiden, what happens here now? If I multiply negative 2/5 times 5 over 1, can I cancel anything?
Yeah.
Good. Well, I cancel the 5s. Good. I could either cross-cancel, or if I want to, I could multiply straight across and get negative 10 over 5. Either way, what do I end up with if I reduce this or cancel this way?
Negative 2.
Negative 2. Negative 2 over 1 is negative 2, right? So we end up with negative 2 equals negative 2 plus b. What do I do with that?
Add 2.
Add 2? So, Caitlin, what's my result going to be if I add 2 to both sides? Okay. B equals 0. So b is 0. M is negative 2/5. So what does that add up to as a line then? If I write that in mx plus b form?
Y equals negative 2/5.
Y equals negative 2/5 x. Would I write the plus 0?
No.
No, I wouldn't, right? Then we want to write it in simplest form. That would stay invisible. There's no reason to write it. It doesn't help us. So that's my answer. Okay, make sense?
Yeah.
Okay, so far so good? All right, how about something like this guy? Let's talk about one of these. This is on the second test. Now, I don't have as much data, but this seems to be the one that most people are, well, there's 2 of them that are missing on the second test. This is one of them, not surprising. Okay, so hold on. Let's start off here. Let's think about, before we jump into stuff, we want to write this in slope-intercept form, but it's an inequality. It's not an equation, right? So it's still mx plus b, but ultimately our answer is going to look like y something, right, mx plus b. What's my something? If it's an inequality, it's either going to be less than or equal to, greater than or equal to. One of those options has to go in the circle. Right?
Less than or equal to.
Okay, so it's going to, and we'll talk about why here in a second. So there's two parts of this. We have to know what's the inequality going to be, and then I also need to know what's the line, right? Well, where does the line part show up on our graph?
Three.
I mean, where is it on the graph up here? What's the mx plus b part? Where it crosses. Okay, so we're talking about the boundary line, aren't we? Right? So the boundary line is the solid blue line on here. Agreed? Okay. So the boundary line is the one that's going to have a slope of what?
Negative three.
We always have to go left to right. So we're going to start here. So I go up 2
Over.
and over by 3. So my slope is what?
Positive 2/3.
Okay. So what's my y-intercept just by looking at the graph?
Negative 3.
-3. So my boundary line then just looks like y equals 2/3 x minus 3. Okay? All right, so now we got to pick an inequality, right? So two things we got to answer about the inequality. Are we including the line? I'm seeing, okay, some people nodding, and I'm seeing a couple people shaking their heads. So let's look at this. Think about it this way. If I'm an ant crawling around on this xy plane, tell me yes or no, is the ant on the solution of the inequality if he's right there?
No.
No, definitely not. Not shaded. How about right there?
Yeah.
Yes. How about right there?
Yeah.
How do you know? You're right. How do you know?
Because he's on the line.
Okay, it's right on the line, but there's something about the line that's, what do you think, Austin? Solid line, right? So we know that's a solid line, so we're including the boundary line. If that line were dashed, the answer right there would have been no, because then the line would have been just a boundary, but not a part of the shaded region, right? Does that make sense? It would have only been the part below it that would have counted, but not the line itself. But here it does, because it's solid. So then we know we can cross those off. It's either going to be less than or equal to or greater than or equal to. Which one? I heard it over here earlier. Less than. How come? Ah, okay. Lower half. Now think about it this way. If we take the boundary line, for example, y equals 2/3 x minus 3. What is this telling us? It's telling us that the y value of an ant that's walking on this line is equal to mx plus b, right? But what if we're talking about y values that could be above or below? Think about the meaning of an x-coordinate and a y-coordinate. The x-axis is horizontal. So if I pick a larger x value, does that mean it's more to the right or more to the left? More to the right, but it's horizontal. So bigger means to the right, lesser means to the left. Y is the vertical axis. So bigger means more up, upper, right? What is a smaller y value? A lesser y value would be down, right? So we've got our boundary line here, and we've shaded all the parts that are below the boundary line. So therefore, we're going to want the y values that are going to be less than the boundary line, because they're going to be below the boundary line, right? That make sense? Okay. Y values that are less than are down, right, are lower. Y values that are greater are going to be higher, right? They're going to be above. So our answer looks like y is less than or equal to 2/3 x minus 3. Okay? The other way we could do this, and I don't want to, not to belabor this one, that works fine. But what if we were doing some other problems where it wasn't in slope-intercept points? There's another way we could do this, right? We could use a test point. Which point would we use? What's always the most convenient point, as long as it's not on the boundary line? 0, 0, right? So what if we take this test point right here, 0, 0, and say we're going back to where we don't yet know what kind of inequality we're using. Here's another way to fill in the blank. Well, we already know that the boundary line is 2/3 x minus 3, right? So if I plug in the points 0, 0, should they make a true or a false statement? Is 0, 0, is the ant in the shaded region? It's not. It's not part of the solution. So if I plug in those x and y values, they should make the statement false, right? Shouldn't work. Okay? So let's try and see what we get. If I plug in 0 for y, 0 for x, I'm going to get 0 on this side and negative 3 on this side. Everybody agree? Well, what's a true statement look like?
-6.
0 is greater or less than? Which one? Greater than or less than negative 3?
Greater than.
A true statement is it's greater than. So a false statement must mean less than. And of course, we know it has to be equal to also, right? Because we're including the line. So that's the other way that we could fill in this blank, is by knowing that the point 0, 0 has to fail, right? And the only sign that'll make it fail is less than. Okay? Make sense? Okay, last one. Yeah, maybe. We'll see about this. How about this guy? This is obviously the other one. Obviously the other one that's causing problems. Now this one, though, isn't worth very much. I mean, you can still do well in the test and not get this. But it's not that hard. If you just get beyond the immediate panic of seeing words on a math test, then you're probably okay on this one. Think about the steps that we go through to solve any word problem. What's the first thing we always want to do? What's x and what's y? Define the unknowns. So if we read this, we always just look to see what's being asked for. So what's going on? Principal bought 42 graphing calculators and 15 tablets for that much money, and then later on bought that many graphing calculators and that many tablets for that much money, right? We want to know what's the cost of a graphing calculator. Each one of them costs how much, and each tablet costs how much. So we'll let x equal cost of a graphing calculator, right? Y equals cost of a tablet. Okay, good. So those are our variables. Now we got to come up with some equations. Well, what's one thing we know about graphing calculators and tablets? We know this. 42 graphing calculators and 15 tablets cost that much. If I'm buying X total graphing calculators, how would I say the cost of, I'm sorry, if X is the cost of a graphing calculator, how much would 42 of them cost? 42 times X, right? 42 times the cost of one calculator, right? Does that make sense? So one equation is going to be 42x, and then if the cost of one tablet is y, but I'm buying 15 of them, isn't that just 15 times y?
Yeah.
That's going to be the total cost of the tablets, and we know that that adds up to 8763, right? Where do I get that other equation? Well, right here, right? 26x plus 22y equals 7904, and then from that point, just use Desmos. I don't want you to solve that algebraically. Once you get the right equations, just throw them in Desmos and find the point of intersection. Okay? Make sense? All right, we made it. Good question.